All right, good morning, everybody. Welcome to another episode of Breakfast with Data. And in this series of deep dive with DataFrame, we'll be continuing where we stopped yesterday or in the last session, which is inspecting the data frame when you have a data frame. Yesterday we did a little bit of pre-flight checks as to when you have a data frame, what are the things that you should do first, like things like count, knowing the shape, knowing how many rows and columns, taking a sample, viewing your data. I mean, those are some of the stuffs that you as a data practitioner or analyst or engineer, depending on who you are, want to quickly do anytime you get a new data set, right? It's the first thing that you want to test. You want to make sure that everything is actually in the place that in the right place. It's in the place that it's supposed to be. Today we'll be taking a deeper dive into some of these and selecting a slicing and dicing and going deeper into things. I mean, this is where you start doing your data wrangling, trying to make sense on a column by column level. And there are different ways that this will happen in pandas. Now you can dig deep into this and dig it deep into it. You start getting more sense of what your data is. Continuing with how we were doing this before, we'll look at how do you do that in pandas and how do you do it in PySpark and DataFrame. Both of them are DataFrame. I hope you still remember what DataFrames are. We did that on the first day, explaining why this. So in case you're joining for the first time, please you can go through the library so that you are up to speed as to where we are and where we are going. Thank you very much. Without further ado, I'm going to jump into the script now, into the class now, and I hope you can see my screen, my live audience, and we are not doing as yesterday. So the first thing we need to do, like, we need to import pandas. Import pandas as PD. This is like what we have to do always. And I'm going to run all um the pandas command first. Then I will look. Then we'll go to PySpark. We'll do it today like that. So I will go through some of these steps. Then we do the comparison that we want to do. So let's have a df and call this pd dot read underscore csv, right? And we are going to pass in one of our CSVs that we have in our volume. So you might want to have, and this location can be anything. You just need to know it can be anywhere. It might not be on your volume. It might be in some other location. You just need to know where you are reading it from. So I'm going to take the student data CSV and I'm going to copy it so that we have a student data frame. Of course, you can change this from DF to student depending on what you're trying to achieve. Now, when we look at this data frame, if I run this now, if we look at this data frame, we have student ID, first name, last name, year group, and email on it. How do we select the different columns in it? Actually, there are close to 5 different ways that we can slice into data frames in pandas. The first one is the dot notation, just like you are picking an attribute of a function. So if I do df dot first name name and I run this, I should get a pandas series. This is a series because it's just one data frame. So if I can put this in I think I can put it in a display. display so that it appears. Can you display? Display is not defined. Okay. Display. I'm missing the spelling. Good. So we can see, okay, there isn't any difference like that. I'm just going to leave it as it is because it doesn't give me any fancy look. I was expecting it to show a little bit better, but again, we get a series, and this is a panda series, and everything is just like you have in a list, and it's showing us the different names of students in our CSV. This is the first name. Now, this dot notation is good, but you shouldn't be using it in all cases. You should not use it in production. This is the reason is that suppose this thing has a data frame may have a column that has space, right? A CSV may come with column name with space. It might come with hyphen, right? You can't have that, right, in Python. So you must always have the name all together, and maybe it's like this, right? So if there is space, if there are hyphens in between, it's going to break. So you want to do the what is it called, the proper way, that this don't use this is good for quick one. And if you even pick a special word too, for example, let's say you pick like dot count, right, which is a valid valid something inside it. Are you saying that this is a method of this thing, and it can be, can you see how this is just like it's not giving you what you are expecting? And you could have this is a method of a data frame, and you could genuinely have a column named count on your data frame, right? This will return something wrong. So always make sure you are not using this in production. You're just trying it. You're just, I mean, and it's not that popular. Maybe most tutorials you may not see see the this thing. I mean, the syntax looks clean, but don't be tempted to use it. The proper way, I mean, the one that most people use is to use subscript, right? Using the bracket notation and passing in a single column here. So when you pass in first name, right, and we run it here, we are going to get the same thing. This is every single time. Suppose the column is named first name, which is not in this particular case, and we run it, we'll get an error here now that first name does not exist. But if we do have that column named first name, you're going to see that that will actually work. Unfortunately, we can't edit here. I would have edited it in this. Let's say I just change the name to first name so that we see that that is definitely still going to work, and you don't have any problem with that. Now, this will return a series and it work regardless of how the column is named. So even if it is space, even if it, and this is your default if you are in production, if you want to get a list of something. Now, what if we want to get multiple if we are trying to get multiple notation, multiple columns, right? We can use this bracket notation with multiple columns. Say I want to get the first name, and this one will now return a data frame, not a panda series. So let's say I want df, and I have so I have first name here. Let's say I have first name, last name, and I want year group. So I can pass this, I can copy this. Let me just copy this guy and take it here. and we are just going to put this in quotes. It's not going to work like this because we need to pass it in as a list of columns, right? So inside this, we are going to put this our bracket again, right? And we'll pass this in. And if I run this now, this will give me a data frame that is just a subset of that particular one that we have earlier. Of course, because this is now a data frame, I can wrap all of this in display so that it's more display. Oh, I mistakenly have my caps lock on display. And we run it this way, we get something that looks even much more neater and much more cleaner. Of course, we can add because it's a data frame, we can now do .add here just to see the first 5 also. So are you seeing how? Or we can do .sample like I showed you yesterday. So this is how you select multiple column. Now there is another way that we also look at this, is the label based. So pandas also have this way that we use the label, right? There is this lock method. So if I do df loc, which is the location, right? And if I want to, so in this will take an argument of the row and the column, right? Suppose I want all of the rows, right? So this takes 2 arguments, row and the column, right? If I want, the first argument that I will take is the row, right? And if I want all of the row, I'm just going to give it a column, right? That will bring every this thing. If you can do this, you can do this. And if I were to run this, you will see that everything will show here, every single thing, right? All the rows, all the column. But we don't want that, obviously, right? Let's say we are interested in just the in just the first name, so if I do first name, let's just copy it from here so that it's faster. And I need to just run this. Now you see that we are back to that series. So it's just like the same thing as this, but this is a little bit more precise, and I will explain to you why it is more precise and why in some cases why you should use the label, so that you are very sure of what you are picking, what you're selecting from a particular um, data frame that you are using. So now, what if we decide to say, let's add more? Let's say we want to add beyond just having, in fact, let me go to another another cell. We can't run out of cells. So let's have it in another cell here. And let's say I want to have multiple columns like we did the other time. We can do this and pass in. We can pass it in as a list. Remember, we passed the other ones as a list, and then we separate this, and we have in fact, let me go and copy the other one so you can have all of this. I'm just going to take 2 and okay. Then let me remove this one so that I have just first name, last name. And one of my what's going on here? Lock. One of my, this thing is not closing. So I put another one here. Good. We are balanced now. So this will give me all of the rows, including the for, and because this is a data frame, it gives me all the rows, but with the selected columns. I can now do I can put this all in a let me wrap it with display, and if I run this now, we have a more cleaner looking table. So this is first name, last name, first name, last name. I always like to, when I want to see something, to have this display in to Pandas, so that it's easier for me to view it as a table. It just looks neater to me. Not compulsory, not totally not necessary, and this is unique to Databricks. I mean, if you are running this on your VS Code, it's definitely going to appear slightly different. Okay. Now there is also another one. Okay. No, maybe we should try one more. Suppose I want the first 5, right? Since most of the things we've been doing here have been focused on running just the columns. We can also select rows as well. So I can start from, so I can do 0 to 5, right? Instead of having this thing. And this is going to give me actually it's going to give 6 this thing, because this is 0 based. So the first one, which is 0, 1, 2, 3, 4, and 5, right? So we have the first 6 actually rows on this particular this thing. Suppose we pass in 1, sorry, not 21, 1 to 5, we will see that it's starting from, and it's starting from the second on the row, not the first. Please don't pay attention to this. This is added to the data frame. Just it's auto generated, so it's this. There's no column with 1, 2, 3, 4, 5 on the table. This is just the rendering of the series, the indexes that it gives it when it's presenting it. So I'm just going to leave it at 0. Can we also, now you might be asking yourself, can we have something like this for, what if we don't want to pass in the list? If we just want to go from one column to the other as well, yes, we can totally do that. And I'm going to show you this other approach, .lock, and I can do, instead of this, I can just do the year group here. Yeah, group, and I can run this now. And can you see that it's like it's moving from year group? If I put, instead of year group here, if I put email, so this is more like a range kind of thing. So as we go to give me everything, I think we have 4 columns here. No, we have student ID, so it eliminates student ID. I could actually start from student ID as well and go all the way student underscore ID. But I hope that helps you understand the different ways you can slice. These are the 5 different ways that you can we've only done 4. I've done lock. I've not done, okay, lock is label. iLock is position. So you can actually use position too, and it behaves almost like lock. It's just that the rows and columns, you are using the position of the row and the column. So let's look at this. So if I do df, right, df.ilock, right, and I do let's say I do rows and column, and the first column, remember, it's Python, and like most other programming language are zero based. They use zero based indexing, so the numbers counting is going to start from zero. So zero is always the first number. So if we do this, what do we get? We get a series, right? And this is the student ID column. This is the first column in this particular table. If I want to pick just the second one, so if I want the first name, are you saying it? Amara, Kwame, Priya, Carlos, Obi, Ravi, and so on and so forth like that. This is iLock. iLock is very, very precise to the positioning of this thing. Now, if what will happen if I pick, I have 1, 2, 3, I have 5 columns here, right? And what if I do 5? 5 will be in position 6. Index will be out of range, right? So index error, single positioner index are out of bound. So all we can do here is we can do, right, to make sure we pick the last one. So when we do -1, we are always picking whatever is the last column in this particular index. What if we want to pick multiple columns, right? I can do, let's say we'll do this as well, and we have everything, right? And I can have everything. Just make sure that you are doing position. I can do up to 3. And what do we get here? We get the first 3 rows, the first 3 columns, sorry. So we have student ID, first name, and the last name. Now, what if I just want some specific columns based on their position? For example, I can pass in let's say the first one, and the third one, and the 5th one. If I run this now, this gives me all of this, right? And let's say I just want and we can put this in a display, right? So that is neater, it looks display. And then we have what we have the iLock. Now, what if we want to do certain and I'm going to just copy this. If we want to get a specific number of rows, so let's say we want to get the first 10 rows and the first 3 columns. How are we going to do that? Very, very simple. Here we put in 10, right? And this is actually, and we can give the first 3 columns will be I'm just going to use the column 3, and if we run this, can you see? So we get the first 10 rows and the first 3 columns. That is how we slice and dice in Python. It's very, very, I mean, most of the time the one that is always safe is always to use this lock. Just use your lock, and instead of iLock, just use your lock or iLock, depending if you know what you are looking for. Any questions so far? So good from my live audience. Mafi, go ahead.
Sorry, I'm trying to identify the tiny difference between the iLock and the lock. So when you use lock normally, and you used when you wanted to pick the first 5 rows, we noticed it was using the 0 base and it brought 6. But for the iLock, when you use 10, it didn't use the 0 base. So is that like the major difference between them both?
Not the major difference, it's just how they are interpreting how the methods are working under the hood. So 0 to 5, that's for the row. The row is counting from, so when you do 0 to 5 here, is counting. Is a slight difference, but iLock is the positioning, even the columns too, they have the position, right? In lock, you introduce the column name. You have to put the column name as a second argument, right? But with iLock, is always the column's position. Yes, you are correct. The way they handle the indexing under the hood is a little bit different. But that's not the only difference.
Thank you, sir.
All right. Let's now go to maybe I should even show you one this thing. Suppose you want to do let's say you are trying to, why should we even use lock and not just use the column name directly? Let's say I want to if I want to filter, maybe I want to dice down. You know, if I do df, I think we did this before, and I say, let's see what we have here. Okay, year 11. Let's say I want all the students in year 11. I can do df and passing that df, and I can do year group, group, and see, I'm filtering the larger data frame based on, you know, this will return a series, right? This is like you are returning a list, and that list, right, I'm now going to set it equal. So this is more like a conditioner. It's now looking at if is equal. So this will be true or false. Anyone that is true of this will be returned to the larger data frame. And say I want the year 11 that we just copied, right? If I run this now, I should get a data frame of everything. But let's say I just want to update the email column. I say, let's do this, and let's add email, right? Email, and I run this, right? Then when I now want to say, let's say I want to update the emails, right? To okay, I can set the email to be equal to update. Let's say update let's say Greenfield Academic GFA .edu. We can decide to do .ng and this. Now this is a very, very, very risky operation to be doing, and thank God this guy is warning us. In fact, this is a caveat that is, and you can go read this documentation. A value is trying to set on a copy of the slice of a data frame, right? Try using .lock instead. So in fact, so if we go back, you see that let's try and see, I think this one. Let's just use this, right? And copy this. If we run this again, we are going to see that we still have this stuff, right? They did not change, right? If we force this is just not going to work, right? But we thought it should work because we have already sliced it to what we want. The best way to write this, or the most appropriate way to write this, let me just put it under this. if we want to update, and again, should not be updating everybody's email to go to the same thing anyway. So let's do a df lock, right? And we can then, I can just copy this, everything that is inside this guy, and just copy this slice first, right? You know the location, I can just copy the first command, which will be the rows I'm looking for, right? df lock. No, I'm making a mistake here. Let me just write it out so that I don't, that's like copy and paste want to wound me in this particular case. So let's do the df, right? And pick the year group that we are interested in, the year group column, year group, and we want when that year group is equal to year 11. Year 11. Always be careful, especially when you are comparing string to each other. And remember that this will give us the row, right? This will be the row, and then we can specify the column, right? So we can specify the column. The column we are interested in is the email column. We can do email here. Now, if we run this just like this, we can see that this will give us just the series of the email, right? Now, we can set these emails to be equal to what we have before. Let's copy this, update, and I can paste this here, and we can just have this. So if we run this now, it will run fine. If we go and run this after, we are going to see, you see that the year 11 has now been updated. So just be careful when you are using the slicing and dicing. Always use label. Lock will get you into the exact column that you are interested in. I think this is enough time on pandas so that PySpark will not be feeling jealous. Let's see. Now, with PySpark, it's a little bit interesting, and you might, depending on what you like, you might find what is it called, more interesting. You might find pandas more interesting, depending on your choice or what you're doing. I think both can work together. It just depends on the context on which you are working, how big your data is. If you like pandas more, you can totally continue using pandas. If you prefer Spark, yes, use Spark. So we can do from PySpark, because we will need some functions. We will need functions like concat, maybe col is the most important one. We need the column name, but we can do from PySpark .sql dot functions can do import col, that's the column, and we can do lit or par, depending. There are a lot of different things. We can do lower is for lowercase, uppercase. If we want to join two things, we can bring in concat. And those of us that like SQL a lot, we already be seeing that there is a lot of things we are used to that are coming here. PySpark. Did I write it very well? Oh, sorry. This is the mistake. Upper. Good. We are fine. Okay. So we can now bring our df spark, so that we don't mess with our original data frame variable. Can set it to be equal to spark dot read dot csv, and we can pass in the csv path. Now if we run this like this, you already know what is going to happen. It won't pick the first row as the header, so we have to tell it header and set it equal to true, right? And then in for this case, we can just infer schema. Don't do this in production. This is one of those don't do this at home kind of thing. But this case, you can do it at home. Just don't do it at work. Schema is actually it's not like it's going to break anything. It's just going to give you what it can infer. And when it cannot infer anything, it's going to default back to string. From a data quality perspective, and as someone who works with these tools in the field, it's always better for you to just have define your own schema, know what schema you are dealing with, other than letting it infer schema for you. But we are doing something that is not too much, so we can always see what this is, and this is a tutorial, not a lot of this thing. Okay, now that we have our spark, you know that we can use df to pick columns like we were doing. It's very, very easy to me in Spark that it is in Pandas. You can just do dot select, because it follows like that SQL dialect, right? Select is a method. Then we pass it in and we say we can do first name. First name, right? And if we run this now, we can see that it's bringing first name. It's a data frame. Let's do display. Let me just see, because this will be a display. So this will bring, you know that when we pick just one column in pandas, it's bringing us a panda series. In this thing, in Spark, it's that column. So for example, if we want to check, I can say print type and pass this guy in, so that we even see what we are dealing with, so that it tells us it's still a data frame, right? So it's not a PySpark series unlike pandas, right? So this is a data frame that is coming for us. And of course, let's say this is just one column. If we want multiple columns, in this particular case, we can do multiple columns, and we can this select that we already have, can do comma, and I can do last name. And when we run this should give us the first name and last name, right? And you can also work from list, from these things, depending on how you are doing. Now, we can use column to do this same stuff. Instead of first name, last name like this, we can actually pass in this and say, which is, I will also explain to you why this is better approach than just doing this thing. So we can do a select and pass in col, col, and pass this in col. When you also want to do transformations on them, it's always safest to use the col. You see that it's returning like the same thing. Now let's say you want to do if we look at let me look at let's say I want first name or last name to be in uppercase, and let's say we want the you know, all those things that we used to do in SQL, right? Say I want the full name, which will be a concatenation of first name and last name, which is why we have this concat. We can use this concat, this thing that we brought in, and then we'll need space in between. And so what I'm going to do here, so let's just do this. Let's get into this. So I'm just going to say df spark, right? And I'm going to say dot select to make this neater. I'm just going to open this on. Now I can select col, the first name, of course I have to put it in quotes because first name is not a variable, so I'm going to put it in quotes, first name, right? And I can do the second I say second name. I can do the let's say last name in uppercase, and oh, this is definitely not what I was trying to do. Okay, let's now do last name in upper, and I can do upper, col, and I can say last name, right? And another interesting thing here is that since I have it as upper, I can actually also look at it from, I can actually alias this as well, so that the name that it appears on can do alias. Is that the correct spelling of alias? I think it is. Alias, yes, it is. Turns to green and it's showing me this. I can give it another name in our listing and say, let's say this is surname. We'll call last name surname in Nigeria. So let's just do that. Surname, and let's say upper, right? Surname upper. And I can do comma here. Why is it ruling line for my surname upper? Let me try and run this. Okay, everything is fine. No error. I don't know why that error is coming from. Now, suppose I want to now have, this will be the long one. Suppose I want to have another column called, and let me even put this inside the display so that we're already seeing how it is looking. So I can put display out here. Display. Alright. This display is a Databricks kind of thing. If you are doing it on another this thing, you might not be seeing that. Can you see that the first name is Amara and John said all the last names are now in uppercase. Now suppose I want to have the full name, another column called full name. I can do this. I can say concat, right? I will now have the different column. So col first name, first underscore name, right? And I can do comma. All right, that's the first thing that it will bring in. And I can do col last name, right? So concatenation is going to try and concat these two now, and I can alias it as well, dot alias, but this is not going to appear very fine, hence we need to introduce space. But let me show you how it's going to look first. Full name. Now if we run this, you can see that this is not looking tidy, right? The names are in this Pascal casing kind of this thing, which does not make sense. Obi Diallo now is reading it as the same name. Now what I'm going to do here is to introduce lit in between. So just that empty space. So I'm going to put an empty space here, and I'm going to say lit, and we are going to put this. And if we run this now, we can see that it's now appearing very well. Amara Johnson, Kwame Asante, and this is good. Any questions so far? So good, so good so far. Any question? Okay, let's look at, maybe we should or else can we quickly look at let's look at another data frame. Maybe we can take another data frame. Let's look at our, okay, let's look at these courses. Murphy, your hand is up.
So without delete, what's that concat work if you just put your ordinary space there?
You said what?
In the
Okay,
concat,
without delete. Let's see. I think it should. Okay, this is why cannot resolve. Do you mean any of the following? No, it's not going to allow you. It will get an error. So let's just do lit. Right. So let's say and again I can say course courses URL and set it equal to this particular string, so that we can decide to bring this in. And if we look at this, our courses, let's take a quick look, and I'm going to just do this in Spark instead of using, because of our time, let's just do this in Spark. I'm going to bring this in, and I'm going to say let's say courses, and let's set it equal to our courses Spark. let's set it equal to spark dot read dot csv, and I'm just going to say bring in this URL that I already have from before, right? Because it's URL, and I'm going to add the header equals true. Header equals true. No need to infer schema, and I can just display courses spark so that we even see this thing clearly. So we can see that this is all the different this. Then if you look at this, you see that this Baba is looking like lowercase, and it's not making sense. We can correct it just on the fly like that using this our column, and we can do some trimming. We can do courses. Remember, this is like a new data frame that we are reassigning to the same data frame, Spark, right? No, this will not. To make sure, again, always use copy and paste too, so that we are on the same page every single time. So I can do courses Spark and set it equal to same course Spark, but dot select. If you look at this, it's not even only that this one to some SQL fundamentals. Well, we can leave those ones. I think course code is the only thing that we are interested in, and I can do dot select and have this, and you know that we can have this. So what I'm going to do, I'm going to trim. Oh, I've not even brought in trim. So let me do upper first. So we are going to do upper the column that we are interested in, upper. So when you use upper or lower, always, and you want to make sure that this thing is the same thing, we want to replace the same column, you have to always do the you have to always add alias course code, right? And to make sure, I think we are copying it very well. Can do dot alias, and we can alias it as the same thing that we are picking it from. We have this here and course code. Then we can have the same other this thing co, and have this was this course name, right? Can take this course name straight and just paste here, and we can do another one which will be the department, and we can also have the credits called credits. Of course, you can do trimming here to make sure credits. Okay, it's credits. Command Z. Credits. Of course, you can do trimming here to make sure if there are any trailing white space or anything, trim is going to remove it for you. But let's run this just as it is. And if we come back and run display this, you see that CS that lowercase would have gone away. Now I have a clean table that CS 102 is now in uppercase, not CS 102. So again, always remember when you are this is where I think we are going to stop now for today. Always remember some of the issues we have earlier when you are trying to assign. Always when you are in Pandas, use lock. Don't forget to use lock. And when you are selecting and you are doing alias in Python, for example, this is, maybe I should even show you this. We have the, let's say if I do let's say I want to, if I do df spark, or let me just say courses spark, all right, courses spark dot select. This is one of the reasons why you should use call dot select. And let's say I want to select course name as, I just want to call it courses, right? And I want to pick this as courses, right? If I want to have the course name and I want to have it as courses, I can do this and say dot alias, right? And I say, instead of course name, I just want course, right? If I put this in a display, it's actually going to throw the error, and we can already see display. And I run this, we'll get error, attribute error. You cannot just alias a string. It needs to be a column. Of course, I can just come here and put column. See why we need to use column, COL. And if I run this now, everything should work fine. Always use that, and be very careful about the how you work so that you don't get keyword error. Be careful with your slicing and everything. Any questions? So far so good. Okay, in the absence of questions, I think we are right on time. Thank you for thanks for watching. This has been Breakfast with Data. Do have a lovely day ahead. Enjoy the rest of your day. Thank you.